All right, so for our second lesson today, we're covering a couple sections, talking about how to evaluate trig functions exactly, and then we will also get to how to use them to solve some problems, answer some questions. So first example here, we want to evaluate all 6 trig functions for 30 degrees. Now, to answer this question, we want to start by thinking about what a triangle would look like if we had a right triangle, and if one of the angles is 30 degrees. So I want to point out that if one of the angles is 30 degrees, then the other must be 60 degrees. And so to answer this question, we can use that special 30, 60, 90 triangle that we learned last class. So in that, the side across from the 30 was 1, across from the 60 was radical 3, and across from the 90 was 2. Now, we could also use the one that had the x's in it, right? X, 2x, and radical 3 times x. But it's not necessary. We can do this for any of these triangles. And so to find the, to find the sine of 30, again, remember sine is opposite over hypotenuse. So for that 30 degrees, the opposite side is 1, hypotenuse is 2. So the sine of 30 is 1/2. To find the cosine of 30, cosine is adjacent over hypotenuse. Well, for the 30, the adjacent side is radical 3. Remember, don't use the hypotenuse. Use the other side next to the 30. And then for this triangle, the hypotenuse is 2, so 2 right there. For tangent of 30, opposite over adjacent, so that'd be 1 over radical 3. We want to simplify this. We remember we can't have any radicals on the bottom. So I'm going to multiply top and bottom by that radical we don't want. So multiply top and bottom by radical 3. So the top is radical 3. On the bottom, radical 3 times radical 3 is 3. Okay, so there's sine, cosine, tangent. We can also find the others. The cosecant of 30 would be 1 over the sine of 30, so that'd be 1 over, instead of 1 over 2, it'd be 2 over 1, or just 2. The secant of 30 would be, again, flip that cosine, so it'd be 2 over radical 3. Once again, we have to fix that. We have to multiply top and bottom by the radical we don't want to be on the bottom. So we get 2 radical 3 over 3. And then the tangent of 30. Again, I always recommend when you flip these, I'm sorry, that should say cosine, cotangent 30. So let's see here. So finally, for the cotangent of 30, again, go to the original fraction we created. Instead of 1 over radical 3, it'd be radical 3 over 1, which is just radical 3. Okay, so we can find the value of all 6 trig functions for 30 degrees. Notice by doing a slight tweak, we can find the same thing for 60 degrees. And actually, we don't even need to do a whole lot of work for that. Remember, we had that little trick. We had that little trick at the end of the last lesson where we said that the sine of 30 is equal to the cosine of 60. So the cosine of 60 would also be 1/2. Cosine of 30 would be sine of 60. Tangent of 30 is equal to the cotangent of 60. Remember, this is all because 30 and 60 are complementary. They add up to 90. The cosecant of 30 is equal to the secant of 60. The secant of 30 is equal to the cosecant of 60. And the cotangent of 30 is equal to the tangent of 60. We could absolutely find all 6 of those ratios for 60 degrees by doing the same thing. Look at the triangle, find opposite over adjacent. But if we remember that relationship, we can save ourselves some effort. Okay, let's ask the same question here for 45 degrees. Let's once again draw a little triangle where it's a right triangle. I do want to remind you guys, at least at this point, we're only working with right triangles. We will go beyond that later on. But for right now, when we talk about all the trig ratios and so on, we always work with right triangles for the moment. If one of the angles is 45, of course, the other one's going to be 45. So this is a 45, 45, 90, which means that the sides are 1, 1, and radical 2. So the sine of 45, it doesn't matter which one you pick, just pick one of the 45s. Opposite is 1, hypotenuse is radical 2. And we rationalize that. And so we get radical 2. The bottom is radical 2 times radical 2 is just 2. So sine 45 is radical 2 over 2. Notice for cosine 45, it's also going to be the same thing. It's still 1 over radical 2. So I'm just going to write the answer again. Tangent of 45 is 1 over 1, which is just 1. Secant 45. So we flip the, I'm sorry, let me do, not that the order matters, but maybe consistent here. Cosecant of 45 would be 1 over the sine, so radical 2 over 1, which is radical 2. Secant of 45, again, just take that cosine and flip it, so it'd also be radical 2. And then cotangent of 45 is also going to be, well, flip the 1 and you get 1. Okay, so we have all 6 trig ratios for 45 degrees also. Now, I'm going to take all these and put them into a table, and you really want to commit these to memory. I notice every number on this chart you could figure out on your own, as long as you remember the basic, or remember the special triangles. You can figure out all of these, but we use them so often that you really want to commit these to memory. And if nothing else, you absolutely want to commit these 6 to memory, because these are definitely going to be coming up again. So, and we're going to be using them a lot in this course. So definitely want to memorize all 6 of those, if nothing else. Okay, now, this is great. This helps us to find the sine of 30, sine of 45, sine of 60. But now the question becomes, what if it's not one of these nice numbers? What if it's some other random number? And the answer is, we're going to use our calculator to come up with some answers. So before we do that, we're going to talk about how to use your calculator to do these problems. Before we do that, I want to make sure that your calculator is set to the proper mode. So right now, we'll talk about how to set this up on your own in just a second. But right now, I'd like you to please type the sin button and then type 30. Now, we know what we expect the answer to be. In fact, we just figured it out. Sine of 30 is 1/2. So if you hit enter, you should get 0.5. Now, if you got a different answer than I did, what's happening is this mode right here, where it says deg for degree, is set to something else. Now, every calculator does this a different way, but what you need to do is figure out how to make that, instead of saying something else, you need to make it say deg for degree. On my calculator, it's this button here that says DRG. Notice if I press that button, it's going to switch. I can make a switch. Deg, rad, we're going to work with that later in the course. It's short for radians. And then GRD is short for gradients. Anyway, you want to make sure this is degrees and then hit enter. So again, once you change that mode, hit equal sign, and again, you should get 0.5 for sine of 30. On this calculator, let me show you do it on this calculator. Notice this time if I do sine 30, it's giving me the wrong answer. It's giving me a totally wrong answer. For a graphing calculator, the way to make the change is go to this button that says mode. Yours might look a little different than mine, but I'm going to go down, see where it says radian. I'm going to move the arrow over till it says degree, and then I'm going to hit the enter button to make the degree highlighted. And we quit. Let's try again, sine 30. And now I'm getting the right answer. Okay? So again, try this out. Make sure you're getting the same answer that I am. Let's try another one. How about cosine of 60? Type in your calculator, see what you get. Again, we expect to get 0.5. If you're not getting 0.5, make sure that you are changing the mode to be the proper mode. Okay, again, we have not talked about how to use this to solve problems. I just want to make sure that your calculator is set to the proper mode. Okay, so let's talk about how to evaluate these. Okay, so let's find sine of 75. So again, on my calculator, to do the sine of 75, on my calculator here. Now, on my calculator, I'm just typing the sine button and then typing 75 and getting an answer. Okay, and we'll talk about how to use this in a little bit. I'm just typing a number, getting an answer. Yours might work a little differently. So for some of you, you might have to type the 75 first and then type the sine button. It just depends on what your calculator does. And so it's about, getting used to your calculator, figuring it out. In my experience, when your calculator has two different lines of readout, the first line shows what you're calculating, the second line shows the answer. In my experience in those calculators, you would just type the sign and then the number. Whereas if there's only one line of readout, so like this one's not there and all you see is the answers, then you might have to type the 75 first and then press the sign button, and that would give you the answer. But again, it's all about learning your calculator, figuring out how to do it. But anyway, we did, so I'll do it one more time. Sine 75 is equal to 0.97. And so I'm just going to write that. Sine 75 is equal to 0.97. Okay, so we can use our calculator to come up with an answer. So let's play around with this. Tangent of 67. Again, I'm just going to type it in again. Tan 67. And I'm getting 2.36 on my calculator. And then, okay, now, secant is tricky because notice that there's no secant button on the calculator. Oops. There's sine, there's cosine, there's tangent, but there is no secant button. Oops, I don't know what to do. So to answer this question, what we have to remember is that the secant of 52 is 1 over the cosine of 52. Okay? In order to evaluate secant and secant and cotangent, we need to convert it into the three buttons we do have, sine, cosine, tangent. So on my calculator, go back to the calculator now. On my calculator, I can type 1 divided by cosine 52. Okay? And so this gives me the answer. And so this is now my secant. So I'm getting 1.62. Okay. 1.62. Okay? Let's take a look at one more here. Cosine 30. Now, I do want to point out, we could do this problem without a calculator. In fact, we found cosine 30 already. But we could also use our calculators to get an answer. Cosine 30. And so I'm getting 0.87. So I just want to point out, it is possible to find the cosine of 30 with a calculator. It is also possible to find without a calculator. Remember your tests. Part of the tests will be calculator, some of the tests will be non-calculator. So you want to make sure that you're able to do both methods. Okay, so each of these problems has dealt with whole degrees, 75 degrees, 67 degrees, and so on. The next thing we want to do is talk about what if we want to take a degree and break it up into smaller pieces. And it's possible to do that. So to break a degree into smaller pieces, we're going to use degrees, minutes, seconds. And actually the whole minute-second thing is kind of set up the same way we've done, you're used to telling time. So 1 minute, which we abbreviate with 1 in this little apostrophe thing here, that's 1 minute. 1 minute represents 1/60th of a degree. Just like 1 minute in time represents 1/60th of an hour. And then 1 second with degrees represents 1/60th of a minute. Again, that's what we're used to, which represents 1/3600th of a degree. Okay, so basically there's 3,600 seconds in 1 degree, kind of like there's 3,600 seconds in 1 hour. Okay, same idea. So let's think about this. Let's play around with this. And we'll talk about how to do this with calculators and also without calculators, because your calculators will actually do this for you as well. So let's see here. So let's start by adding these. Okay, so we got 27 degrees, 5 minutes, 17 seconds, plus 35 degrees, 17 minutes, 52 seconds. Okay, I'm just going to write one over the other. I'll do this vertically. So 27 degrees, 5 minutes, 17 seconds. We're going to add these together. Now, I'm going to add each individual portion. So this is, let's see, how many degrees? That'd be 62 degrees. And this would be 22 minutes. And this would be 69 seconds. Okay. Which is cool, except that it wouldn't make any sense to say 69 seconds, right? 69 seconds represents more than a minute. So I'm going to change this to 62 degrees, 23 minutes, and 9 seconds. Basically, the 69 seconds represents 60 seconds, which is a minute, and also 9 seconds. So that extra minute I'm adding on to the minutes, and then I have 9 seconds. Okay, so there's my answer in degrees, minutes, seconds. How about we subtract 15 degrees, 28 minutes from 90 degrees? Okay, so we have 90 degrees minus 15 degrees, 28 seconds. Okay, this is going to feel an awful lot like second grade, because we are literally going to say, okay, well, I have to take away 28 minutes from something. I'm going to take one of those degrees away, so now I've got 89 left, and turn it into 60 minutes. So basically, what is this called? I think it's called borrowing when you're learning second grade. So we're borrowing 1 degree, turning it into 60 seconds. Now if I subtract these, I'm going to get 32 minutes, and subtract these, I get 74 degrees. So the difference here would be 74 degrees, 32 seconds. Okay. So this is the first part, okay? Just working with degrees, minutes, seconds. Now, it is possible to also convert, let me say this. It's also possible to represent a portion of a degree using decimals, okay? So we can also use decimal degrees, such as this one. So 17.56 degrees. Which certainly seems like an easier way to work with portions of a degree. I'm not going to disagree with anybody on that. But we do want to talk about how to convert back and forth between these. So let's convert degrees, minutes, seconds to decimal degrees. Okay, so 17 degrees, 39 minutes, 22 seconds. DD stands for decimal degrees. And so let's remember that this represents 17 degrees. This represents 39/60ths of a degree. And this represents 22 out of 3,600 of a degree. Right, 22 seconds is 22 3600ths of a degree. So to answer the question here, I'm just going to add these together. I'll do this on my calculator. Okay, and I'm literally going to just type 17 plus 39 divided by 60 plus 22 divided by 3,600. And I'm getting 17.656. All right, now I want to show you guys how to do this conversion without going through this whole process with the fractions. And I'll show you first with the scientific calculator, and then also show you with the graphing calculator. So here's my scientific calculator. So if I type in the degrees, minutes, seconds, as I did before, so Let's see, 17. So to do this on the calculator, to get degrees, minutes, seconds, I'm going to use this button right here. Looks like a little degree and then apostrophe and then double apostrophe. So type that once and it gives me all these options. Again, every calculator is different. You have to learn yours. So 17 degrees, 39 minutes, and 22 seconds. Hit enter, and it'll give you that same decimal. So it's kind of nice that it'll just do that for you. On the graphing calculator, here's what that looks like. I'm going to go to, see where it says angle there, above there, it's in blue. At least on mine it's blue. So if I do second, let me type the 17 first. So if I do second and then that angle button, this is where I can find my degrees and my minutes and my seconds. So 17 degrees, 39 minutes. And 22 seconds. I think that'll do it for me. Nope. Maybe this will do it. Do it again, maybe. Nope, didn't like that. Okay, I'm not entirely sure how to get the seconds on this calculator, but that's okay. Okay, so it is possible to convert. And so notice, even if you're not 100% sure how to do it on this calculator, I'm sure there is some place for seconds. I'm just not sure where. You can still do the same way that I did this problem. Just convert to fractions and then let your calculator do those fractions. Now, we also want to talk about how to convert the other direction. So here's some decimal degrees. We want to convert this to DMS, stands for degrees, minutes, seconds. And so we're definitely going to do this on the calculator. So let me just show you really briefly how to do that on the calculator. So let me type in that decimal. It was 29.538. On this calculator, I'm going to go to that angle menu again. And right there is DMS. This will convert everything into degrees, minutes, seconds. And so it looks like it's 29 degrees. I'll write down my answer here. It was 29 degrees, 32 minutes, and 16.8 seconds. Okay, and let's see how we can do that on the scientific calculator. So here's my scientific calculator. Again, let me type the decimal here. So it was 22.538. For this one, I'm going to go to, let's see, I had a minute ago. Oh, I'm going to press that same button that has all the degrees, minutes, seconds on there. Press that. And then if you keep pressing to the right, there's my DMS right there. And there we go, converts it to degrees, minutes, seconds. Again, every calculator is different. You just have to figure out how yours works. Okay, so we can also evaluate these trig ratios at different places. First of all, evaluating a sign at a decimal degree is you just type in the decimal. So that's not a big deal. So earlier we found the sign of 75. I could have typed in 75.2 and it would have given me the answer just fine. To answer this question, to evaluate this problem, I'm just going to type in, again, inserting the degrees, minutes, seconds as we have been. So I'm going to type, in this case, sine. It was 18 degrees, 9 minutes. Oops. Enter, and I get that as my answer. And again, you would enter it the same way we did before with the on the graphing calculator as well. So I'm getting for my answer here 0.31. Okay, so that would be converting, basically talking about portions of decimals, and then how to evaluate our different trig ratios or different trig functions at those portions. Okay, let's continue to this. Now, okay, inverse trig functions. So now we're going to have to think about this. Let's actually, even before I get to trig, let me ask this question. Let's say I was solving this problem. I'm going to erase these in a minute. So x plus 5 equals 12. Okay, this is not a trig question. The question is, what would we do to get that x by itself? Well, if there's a plus 5, we want to do the opposite of that, which means we do minus 5 on both sides. If it had been, I don't know, 3x equals 15, okay, how do I get the x by itself? Well, if x is being multiplied by 3, we can get x by itself by undoing that, doing the opposite of multiplying, which would be division. So we would divide both sides by 3. And what if I had like x squared equals 16? Well, again, what's being done to the x? It's being squared. So to get the x by itself, we have to undo the squared, and the opposite of squaring something is square rooting. So we would square root both sides. Well, the question we're going to ask here is, what we want to do here is undo one of these trig things, right? Okay, cosine x equals this decimal, that's cool. Well, to get x by itself, I have to undo the cosine. I have to do the opposite cosine. So here's how that's going to look. So first of all, when we had, again, x squared, the opposite of that was the square root, right? Well, cosine x, the opposite of that is called the inverse cosine, and it's the little cosine with a -1. It looks like the -1 power, but it's not an exponent, it's not a power, it's just a little symbol there. That's how we're going to undo the cosine. Now, our calculator is going to do this for us. So notice that to get the x by itself, we want to undo the cosine on both sides. Okay, so we're going to undo the cosine on the left side, we're going to undo the cosine on the right side. Notice that when I do the opposite of cosine on the left side, it makes this cosine go away, so I'm left with just x. I'm trying to get the cosine away from the x. I'm going to do the opposite of the cosine. Now, on my calculator, here's what I'm going to do. I'm not going to press the cosine button, but notice that above the cosine, there's a little cosine -1. That's the opposite of the cosine. That's the inverse cosine. So I'm going to type on my calculator second and then cosine. Okay? So we're doing the opposite cosine. We're undoing the cosine. And then I'm going to type that decimal that I had on the right side. So it was 0.8734. So this now is my x. This is the result of undoing the cosine on both sides. So I find that x is equal to 29.1. Okay? Let's try this one, tan x. Okay, again, to get the x by itself, we want to undo the tangent. We're going to get the x by itself. Try this on your own. Pause the video for a second and see if you can come up with an answer. So if I want to undo the tangent, again, on my calculator, I'm going to type, let me clear this out. I don't want to type tangent. I want the opposite of the tangent. So I do second and then tangent. And then I'm going to type it was 2.752. So I'm going to do the opposite of the tangent, and I'm ending up with 70.0. So on my paper here, I will write x equals 70.0. Okay, so this is how we undo trig functions. This is how we get basically get the cosine or the tangent away from a variable. Okay, now we are going to use that idea, and we're going to use these trig functions to do what's called solving triangles, meaning find missing parts of a right triangle. Now, let me remind you really briefly that when we did SOHCAHTOA, for example, when we did sine, SOH, we said that sine theta is equal to opposite over hypotenuse. Okay, sine is opposite over hypotenuse. Notice that the angle is right here next to that sine. Okay, and likewise, cosine, it was cosine theta, tan theta. The angle was always right there next to our function. Okay, and then the opposite was one of the sides, hypotenuse was the other. So let's keep that in mind when we think about this problem. So here we're going to solve for x. We got a triangle. We're given some information. We want to find one of the missing sides. So to answer this question, I'm going to use one of those three trig functions. I'm going to use either sine or cosine or tangent. So let me write this out. So ka toa. And now I have to make a choice. I have to decide, do I want to use sine or cosine or tangent? And to answer that question, I really want to ask, which sides do I know? We are going to focus on the angle that is given to us. Okay, we're given this 55. We're going to focus on that 55. And we're going to ask, which sides do we know? Well, first of all, notice that that 16 is the hypotenuse. Okay, and no matter which angle I was given, that is going to be the case because it's across from the 90. So my 16 is my hypotenuse. Now, notice that the x, well, again, if I'm focused on that 55 degrees, notice that the x is right next to it, so that x is the opposite side. Nope, it is not. Wow, I'm not even close. Let's try that again. The x is the adjacent side. Sorry. I'd love to be able to say I did that to try to trick you, but I just messed up. The x is the adjacent side because it's right next to that angle that has been given to us. We're focused on just the angle that's been given to us, and x is right next to it. Notice that because I've got the adjacent and the hypotenuse, I'm thinking about ka. And for this problem, I'm going to use cosine. So I'm going to write cosine on my paper. Now, let's remember what we said just a minute ago. Next to the cosine, we always write the angle. For this problem, the angle is 55, so I'm going to write cosine 55. We always put the angle next to the sine or the cosine or the tangent. We know that cosine of an angle is equal to the adjacent side divided by the hypotenuse. So cosine of 55 in this triangle is equal to x over 16. And this is my equation. And I'll tell you right now, for these problems, solving for one of the sides of the triangle, there are two big parts to it. First part is just setting up the equation. And some of you may have worked with some of this stuff in previous classes. Some of you may be able to jump right to the answer, and that's great, but I still want to see this step. I still need to see this step for you to get full credit. This is you showing your work, showing me what equation are you going to actually solve for x. So here's my equation. Cosine of the angle is equal to x over 16. Now, the next part of this is we have to get the x by itself. Okay? Before we pick up a calculator, I know that we can pick up a calculator and type cosine 55, and we'll do that. But before we do anything else, I want to get the x by itself first. So to get the x by itself first, I'm going to get rid of the fraction. Notice that if I multiply both sides by 16, that fraction is going to go away. Oops, sorry, did not mean to do that. So if I cancel those out, I get that x is equal to 16 cosine 55. Okay? Once I've got the x by itself, now I'm going to pick up my calculator. And now I'm going to come up with an answer. So I'm going to type on my calculator. Now again, every calculator is different. On my calculator, I'm just going to type 16 cosine 55. Oops, too many fives. 16 cosine 55. By the way, did you notice that it said cosine 55? So I typed cosine 55. I didn't do second cosine. No, it said, I wrote on my paper cosine 55, so I'm typing cosine 55. For those of you who had to type the 55 first and then the cosine, you're going to type 55 and then type cosine, hit enter, and then times 16. Okay? So again, it's up to you to figure out how your calculator works. But again, if you were one of those folks who had to type the 55, then the cosine, type that first, hit equals or enter, and then times 16. Anyway, we're getting our answer. We're getting 9.2. So x is equal to 9.2. Cool. Okay, let's try another one here. Let's try this one. once again, we have to make a choice here. We have to decide, oh, it's so katoa, that's cool. So katoa. And we have to decide which of these three trig functions do I use, sine, cosine, or tangent. And again, we always focus on the angle that has been given to us. Well, here, the angle is right here. This is x. Now, last time the angle was a number. This time the angle is an x. Who cares? It doesn't matter. Okay? Yeah, so just whatever the angle that's be given to you is, that's what you're going to use to make your choice. From that angle, I'm going to observe that this 2 here is opposite. It's across from the angle that's given. The 17 here is adjacent because it's right next to the angle. Well, opposite and adjacent means we're going to use tangent, toa here. So on my paper, I'm going to write tan. Now remember, what do we always put next to the tangent or the sine or the cosine? The answer is we always put the angle next to the sine, cosine, or tangent. So in this case, the angle is x. So I'm going to write tan x equals. So the tangent of this angle is equal to opposite over adjacent, so that's 2 over 17. I want to take a step back for a second. Last class, I might have asked you, for this picture, I might have asked you to, hey, find tangent of x. In fact, here, let me just write, find tangent of x. Cool. And so you would have written tan x equals 2 over 17. There's my answer. Done with the problem. Okay, that's great, because last time it said find the tangent of x. This time it's a different direction. This time it says find x. Okay, so we're not just going to stop here. We're going to keep going. We're going to get the x by itself. Now notice, to get the x by itself, I have to undo the tangent. I have to get the tangent away from that x. So on my calculator, again, this time we're doing the opposite of the tangent, the inverse tangent. So this time on my calculator, I'm going to type second tan, 2 divided by 17. Equals. Now again, for those of you who had to type the number and then the second tan, so you're going to type 2 divided by 17, hit equals, and then type second, and then tan. And again, you should get the same answer that I'm getting of 6.7. So I'm getting that x equals 6.7. There we go. Okay, so we can use trigonometry, sine and cosine and tangent. We can use that to find a missing part of a triangle. Now, solving right triangles means don't just find one missing piece, but find every missing piece. Solving a right triangle means that by the time you're done, you're going to find every single triangle, you're going to find every single side length. So some things to remember. First of all, when you're trying to relate sides and angles, you're going to use SOHCAHTOA. In the last example, we had the sides, we wanted to find the angle. In the one before that, we had a side and an angle, we wanted to find another side. That's when we used sine, cosine, tangent. But we have some other tricks up our sleeve. We can also remember that the angles add up to 180, right? So if you know 2 of the angles, you can find the third angle by just remembering they add up to 180. And then also we can use this. If we know 2 sides of the triangle, we can find the third side using Pythagorean theorem. So the phrase solve the triangle means find the measures of all the sides and also all the angles. So mostly that means you're going to have 3 different things to find before you're done with the problem. So let's solve this triangle. Okay, we're given, it's a right triangle, so we know one of the angles is 90. We're told that one of the sides is 13 and one of the angles is 25. And we need to find anything else that's missing. So we need to find the measure of angle J. I'm going to label these 2 missing sides X and Y. It's just a little easier than calling them HG and JG. Those are not easy to say. So I'm just going to call them X and Y. So the 2 missing sides here are X and Y. So before we're done, we're going to have to find the 1 missing angle and the 2 missing sides. Well, let's start with the easy one. Notice that we know two of the angles, so we know that we can find the third angle by remembering that 25 plus j plus 90 is equal to 180. And so I end up getting that j is equal to 65. Okay, so there's 65. Cool. Next, let's start with the x. And it really doesn't matter which one you picked, but let's start with the x. Notice that I'm going to have to use this angle to find the side. So that tells me right away I'm going to have to use sine or cosine or tangent, right? Because I'm trying to relate a side with an angle. Well, focused on that 25, I'm noticing that x is adjacent, and I'm noticing that 13 is hypotenuse. Well, I've got adjacent and I've got hypotenuse, so I'm going to use cosine, right? CAH. Cosine is adjacent over hypotenuse. Now, next to the cosine, we always put the angle. So I'm writing cosine 25 equals adjacent over hypotenuse. So there we go. Now, some of you may have asked, hey, could we, instead of using the 25, could I have put the 55 here for angle J and then use that to answer the question? The answer is definitely you could. Yeah, the more information you have, the more choices you have. So you would have gotten the exact same answer if you'd used the angle J instead of angle H. Anyway, to solve this, again, I want to get the x by itself. So to get the x by itself, I'm going to have to multiply both sides by 13 to make that fraction go away. So I get x equals 13 cosine 25, excuse me. And so now to find x, I'm going to type in exactly what I see. It says 13 cosine 25. So on my calculator, I'm going to type 13 cosine 25, and I'm getting 11.8. Great. So x is 11.8. Last thing I have to find is y. Okay. Now, again, you have a choice. You know x. You know 13. You could use Pythagorean theorem to find y. I'm not going to do that, and part of my reason is to do that, I would be using the decimal for x, that's just an approximation, and I would get a better answer if I use the exact value. So, and that's kind of a little bit annoying to do. So I'm going to find y, and also just because it's good practice, I'm going to go back to the 25 again, and I'm going to, this time, use it to find y. And so I'm noticing now y is the opposite. 13 is hypotenuse. Opposite and hypotenuse tell me to use sine, so it'll be sine 25 equals opposite over hypotenuse, y over 13. Once again, I'm going to multiply both sides by 13 to make the fraction go away. So I get y equals 13 sine 25. Once again, I'm going to use my calculator. And I'm getting that y is equal to 5.5. So my last side here is 5.5. But again, as you get more information, you have more choices. You can make different choices and still get the same answer. Also, if you had used Pythagorean theorem, your answer would have been slightly different than mine. But as long as your work is correct, I'm not going to take off any points. As long as your answer is close to mine, and it's only wrong because of rounding, but all the rest of the work is correct, I'll still give you full credit for that. All right, let's try another one here. Let's solve this triangle. And so for this triangle, again, we're missing three things. This time we're missing angle A, angle C, and this missing side that I'll call X. So now we've got three things we're trying to find. Again, you pick whatever order you want to go. Okay, the order really doesn't matter. How about we find X? Okay, and the only reason I pick X is because I know two sides. Let's just find the third side. On the last example, I knew two angles. Let's just find the third angle. So here I'm going to do 2 squared plus 3 squared equals x squared. Please remember that the hypotenuse is always c, right? The side across from the 90 degrees is always c when you're doing Pythagorean theorem. And so in this case, that would have to be the x. 4 plus 9 equals x squared. X squared equals 13. So if I square root both sides, square root of 13 gives, square root of 13 gives me 3.6. Okay, so x is 3.6. Great. Okay, next, let's find angle A. And again, it doesn't matter. Pick whichever one you want. I'll just do A first. So I'm focused on that angle. Again, I'm just going to use the 2 and the 3. First of all, they're nice numbers. But second of all, x would just be a decimal approximation. If I want the exact answer, I want to use the numbers that were given to me. So there's angle A. Notice at angle A, this 3 is the opposite side. The 2 is the adjacent side. So if I've got opposite and I've got adjacent, I'm going to use tangent. Next to the tangent, I always put the angle. So it's tangent A. Right? In this case, the angle is the thing I don't know. It's my variable. So I'm doing tangent A. Tangent A is equal to opposite over adjacent, excuse me. So opposite over adjacent would be 3 over 2. And then once again, to get the A, to solve for A, I need to undo the tangent. I need to get the tangent away from the A. So on my calculator, I'm pressing second, and then I'm pressing tangent. And then 3 over 2, I'm getting an answer of 56.3. Okay, so again, to get the tangent away from the A. Basically, guys, anytime you're solving for an angle, you're going to use the inverse sine, cosine, or tangent rather than the regular sine, cosine, or tangent. Okay, if you're solving for an angle, you're going to undo the tangent, so you're going to have to use the inverse tangent. Okay, finally, to find angle C, let's just use the fact that all the angles add up to 90, or add up to 180. So 90 plus 56.3 plus C equals 180. And I'm getting the C is equal to 33.7. Okay, so there's my 3 answers for this triangle. Let's try one more solving the triangle. In fact, how about for this one, you guys pause the video for a second, try it on your own. Okay, see if you can come up with the answers, and then we'll do it together. Oh, excuse me, I'm sorry, this is not solving the triangle, this is just solving for x. You only have to find one thing. So, try to set this one up on your own. Pause the video, see if you can set this up on your own. So once again, we're going to focus on the angle. We're going to observe that this 9 is right next to it, so that's the adjacent side. And this x is across from the 90, so that's the hypotenuse. Okay. So I have adjacent, I have hypotenuse, so I'm going to use cosine. Now, next to the cosine, we always put the angle. So cosine 41 equals, adjacent is 9, hypotenuse is x. So cosine 41 equals 9 over x. So there's the setup. And again, you want to set these up. You want to show me this work. You want to show me this equation. This is half the points for the problem right here. Now, to get the x by itself, remember our goal here is to get rid of the fraction. Well, notice this time to get rid of the fraction, I'm going to have to multiply both sides by x. This is a little different. I want the x to cancel with this x on the bottom. So this is a little different, right? We're multiplying both sides by x to make the fraction go away, so I get x cosine 41 equals 9. Okay, well, here's the next part. Again, I want to get x by itself. That's cool. Notice that x is being multiplied by a number, right? Cosine 41 is just a number. It's a weird-looking number, but it's still just a number. So to do this, to get the x by itself, I'm going to divide both sides by whatever the x is being multiplied by. I'm going to divide both sides by cosine 41. So that these cancel out. So I end up getting that x is equal to 9 divided by cosine 41. Okay? Again, a little different, right? This time in my fraction, the x was on the bottom, so we had to basically think a little bit more carefully while we're getting the x by itself. Now, back to my calculator. Let me evaluate this here. So it was 9 divided by cosine 41. And I'm getting this as my answer. So 9 divided by cosine 41 is 11.9. Now, one more time again, every calculator is different. So some of you, again, you had to type the 41 before you can press the cosine. So here's how you would type it. I'm going to type it. It's not going to work on my calculator, but I'm going to type 9 divided by. Now, here's what you're going to do. You're going to type the 41, and then you're going to press the cosine button, and then you're going to press the equal sign. Again, if your calculator is not like mine, where you can just type what you see. Okay, so I just got a nice answer. If you're one of those folks who had to type the 41 before you type the cosine, you're going to type 9 divided by. You're going to type 41. You're going to press the cosine button, so that takes the cosine of 41. And then when you hit the equal sign, then it will finish the division problem. And you should get the exact same answer that I am. If any of you are not getting the answers that I am and you just can't figure out how to work your calculator, don't worry. Talk to me tomorrow. I'll be back tomorrow, and I will definitely walk you through how to do these on your calculator. Do as many as you can. Set up, even if you can't come up with final answers on the homework maybe, still set them up. Write this equation so you can at least practice doing that. And then the calculator stuff, if you're not able to, wait till tomorrow and we can figure it out together. All right, one more thing that we need to talk about here when it comes to solving triangles is angle of elevation and something else also. An angle of elevation is an angle formed by a horizontal line and the line of sight to an object above the level of the horizontal. So this is the angle of elevation. So basically it's the angle between looking straight ahead and looking up at the airplane. And then we also have something called the angle of depression if you're on top of a building or on something high and you're looking down. The angle of depression is the angle between looking straight ahead and looking down at the object. Okay, so please notice both of these angles involve horizontal lines. It's just that one of them you go up, one of them you go down. So a man is standing 10 feet from a building. A man standing 10 feet from a building looks at the top of the building so that the angle of elevation is 56 degrees. Find the height of the building. Okay, well, let me draw the building. There it is. Here's a little man, a beautiful stick figure. He's looking up at the top. I'm going to assume, once again, that the building is straight up and down, so that's a right angle. Hopefully it's not too big of an assumption. He is 10 feet from the building, so his distance on the ground here is 10. So notice, I'm not labeling the hypotenuse, right? It's not the distance from the top of the building. It's the distance from where he's standing to where the building is on the ground. 56 degrees. Now again, we have to decide which of these angles gets the 56. And remember, guys, angle of elevation always involves a horizontal line. You want to be careful that you put the angle in the right place. Always involves a horizontal line, so the 56 is going to go right here. There's my 56. Because that's the angle that has a horizontal line. The angle at the top of the triangle is not. It's a vertical line, right, the side of the building. So we're not going to use that. We want the height of the building, so there's my x. And, oh, look, this is a problem just like we saw previously. So let's see. Focused on my angle. Looks like x is opposite. Tan is adjacent. Let's try it again. 10 is adjacent. I gave it away there. We have opposite and we have adjacent. So I'm going to use tangent. Next to the tangent, I always put the angle. So tan 56. And tangent is opposite over adjacent. Oops. I want to get rid of the fraction, so I'm going to multiply both sides by 10. And so I get x equals 10 tan 56. Finally, I'm going to type that in my calculator, and I'm getting 14.8. So it looks like the building is 14.8 feet tall. All right, that brings us to the end of the lesson. So I apologize I haven't been here the last couple days, but I look forward to meeting you guys all tomorrow. And if you have any questions, then we can definitely address those tomorrow before we get to any new material. Thank you very much, guys.